Hey all, how are you all going today? It is Lawrence from Express Unity. Uh, I really don't know how to start my streams. You're gonna forgive me here. But yeah, today I'm. This music is a bit too. I'm gonna pause it for a sec. Um, yeah, today basically I am wanting to just kind of go over making a 2D game engine, kind of just for myself here, for just because I haven't programmed like seriously in quite a bit. I do like the tutorials and all that with PlayFab, but most of the time it's just me repeating what's on the documents. So that stuff is fairly easy to do. But I haven't genuinely sat down and thought of a program without needing any documentation. So basically, this is today. I have not programmed for maybe a little over a month, and I just want to sit down, see what I can remember, and what better way to do that than making a 2D game engine? So, if anyone was wondering, we are not using any any external libraries. Maybe somewhere down the line we might use like Box 2D for physics, but to start with, we are literally just using Windows and Visual Studio inside a .NET framework console application. So right now, if I just play this, it'll just open and close a console window, and we're gonna spice things up a little bit. Um, so usually when I start making a game engine, I kind of want to set up my classes that I'll be needing. So I think the first real class that we will be needing is a vector2 script, or class rather, and basically that's just gonna be the main class that handles all our positions. When it comes to game engines, I think the vector2 script is going to be the easiest thing. Um, what I might do is create a new folder for everything that I want in the game engine. So we'll just call this. I called it Express. What did I call it? Express Engine. Yeah. So I'll call that folder Express Engine, and then inside of here, I'm going to make all the classes that our game engine will need. So before we actually start, I may just make a expressed engine class that we will work with a bit later on. Um, we will also now be using a new class. We're going to call this one vector2. And okay, so the first thing I'm going to do is make the vector2 class public. And this is something you guys could easily follow along with if you wanted to. Just open up Visual Studio and start a new console application. Um, excuse me. Oh yeah, there are some references we need to add first. And this is mainly for drawing, so we don't technically need it yet. But for drawing a window, we need to add reference. And in the assemblies, we want to find system.drawing. This will give us access to the colors, dot red, green, all that stuff. We will also want system.windowsForms, and I believe back to system.drawing. Actually, yeah, I think that might be it. Yeah, I think that's it. Okay, so in the vector2 class, we are simply just going to want a public float, and we will call this x, and that is going to be get and set. And then we also want a public float y. The exact same thing. Get and set. Now, when the class is first initialized, we can do two things, right? So the first thing we should be able to do is basically, if we don't input any values, we want this vector2 to set all of these above values to 0, essentially being vector2.0. So we can make that. So we could just say public void 0. And then all we need to do really is say x is equal to 0 and y is equal to 0. So then if we initialize the class with our first option, which being nothing, then all we're going to call is 0. Now in any other class, this will be vector2.0. But we can't do that here. We want this to be a public vector2, right? And then we want this to return a new vector2. And for now, we'll leave that like that until we fix this up. So we're also going to want a public vector2 that takes a few arguments. The first one will be float x, second float y. Hi Kozu, how are you? Okay, so basically with that we can now set this dot x equal to the x value we pass in, and this dot y equal to the y value we pass in. Now what we can do here is now that we have this initialization method, we can basically get a vector2 and just pass in 0, 0. And then if the class is initialized with nothing, we should be able to just say this equals 0, right? Been a while. Okay, read only, guess not. So in that case, we can do something like x equals 0 dot x, and same goes for our y. And because we want this to kind of be like a global, we're always going to retrieve a value from this and not set it, so we can make this static. And then basically anywhere in our game engine we should be able to just call vector2.0 and pass in and it'll return what we want. So vector2.0, yeah. You're doing good? Yeah, I'm pretty good. I literally just woke up an hour ago. Super tired. And then what we can also do to help us out down the track is if we say vector2.0, IntelliSense basically just shows us the function. If we do // we then get a summary here, and then we can just say returns x and y as 0, something like that. So now if we type in vector2.0, it should give us that. It should give us. It should have worked with IntelliSense. I wonder why it's not, but it's no big deal. Okay, so that should be same here. Yeah, always died. So that should be it for a vector2 class for now. We could do things like add and subtract and all that good stuff, but for now we're just going to keep it simple. And now we'll go back to our expressed engine, or whatever class you call it, if you guys are following along as well. And we're going to make the class a public abstract. And then we are going to want to be using system.drawing and using system.windows.forms, as well as using system.threading. Now we want a few things inside the class. We want a public int. We will actually no, we've got that vector2 class now, so we can do public vector2 screen size, and by default we can make this equal to a new vector2 and say something like 512 by 512. And now we want a actually, we don't actually want these to be public. We want them to be private because we don't want them to be edited outside of the game starting up, because that might cause issues. So private string, and this will be our title. And then we should just be able to set those on when this class is called or initialized. So we want to pass in vector2. We'll call this one screen size as well, and then we want to pass a title, which is a string. And underneath here we will say this dot screen size is equal to screen size, and then this dot title is equal to title. So that should be all our window parameters set for now. Now we want to actually create our window. And by default, Windows Drawing doesn't continuously refresh the window. So for example, Visual Studio here, which is most likely using the Windows Forms methods, the only time this entire window is redrawn would be when something major changes. So for example, if I backspace, this entire middle window here would be redrawn. It wouldn't just be the single line that's redrawn, it would be everything. Same goes if I move this panel. So it'll only redraw particular things when it needs to, because that's how optimization works. However, with our game, it is only going to be one window that is going to display our game instance, and that window we want to continuously call basically as close to every frame as we can. Because Windows Forms isn't designed to actually be a game engine and display and render graphics, it's not very performant, and so we can't do like massive like 2000 game objects sort of things, because it'll just slow down a lot very fast, and I'll show you once we get to actually drawing. But there is a way that we can kind of hack the Windows Forms in a way to do what we want. And the first step to do that is to create a new class. And this class I'm going to call Canvas. And it is going to inherit from the Windows Forms. And then when this class is initialized, basically we say this dot double buffered is equal to true. Basically, if you don't do this and we just force refresh a Windows form, you will get a lot of flickering. So enabling double buffered, which usually is not enabled on any Windows form application unless it's really needed to like get a smooth display. But yeah, since we're making a game, this is needed. So now we want a private canvas, and we can call this one window. And we're gonna start that off as null. Also the title, we're gonna start this off as something like new game or something. So now inside our when our express engine gets initialized, we basically want to say window is equal to new canvas, and then we can say window.size equals new size. Since Windows doesn't actually know what a vector2 is, we will just basically do this and say screen size dot x, and then screen size dot y. The only problem with this is it's wanting integers and not a float, so we need to cast them into integers to fix that. Okay, so now we want to set the window title. So window.title, or rather it's text with windows. So window.text will change the form title, and we want this to be equal to this.title. Also, this will need to be this.screen size, and this one as well. Otherwise, it's referencing this one here, and to be extra sure that all of this is set, we want to make sure we reference our actual game engine's stuff here. Okay, so I think we have the basics of displaying a window. So now what we can do is say application.run, and then we pass in our window, which is our custom window, as it is double buffered. So now what we can do is we want to create, let's create a, why isn't it, a new class, and this will be our demo game. This is where we test everything, so we'll just call this demo game. And demo game is going to inherit from our expressed engine. I think we need to do express engine dot express engine because we're using that folder, which is no big deal. And then what we want to say is public demo game, and then we want to give it a base. And the base, oops, sorry, we don't want brackets here. Wait, do we? I think we do actually. And then the base is going to be our new vector2. And this is going to be, can we do this actually? Can we say using express engine? I'm just thinking if there's a way we can remove that extension, because it's kind of annoying. Okay, there we go. So we need to be using express engine dot express engine. And our screen size, to make it different from our default, we want the width of the screen, let's just make it 615 by 515. Can't wait for this to get started. Hope you're doing well. Yeah, I'm doing great, man. Hopefully you're doing good as well. And then our title, to change it up, will be expressed, I don't know, engine demo. And that should be good like that. So now our error should be removed. This is starting our game engine. But now in our main program file, so program.cs, that is generated when you first launch a console application, we basically want to now start our demo game. So we'll just call it game equals demo game. So, can we use like a method? Oh, equals new demo game. So what will happen here is the main program will call demo game. Demo game will then instantiate the base of our engine, setting all of these parameters, finally running our application. So if we run this now, we should no longer get a console that pops up and closes. We should get a console, and that console will open our game. There it is. And our title is set as well. So this is looking good. We are getting somewhere. That Unity 3D, this looks like making a video game blind. I mean, technically it is, right? Because you have no help. You need to make all the classes yourself. You need to make the rendering system and all that. However, this is way easier than using something like OpenGL, because Windows Forms is pretty straightforward functions. You got like Windows.text, Windows.background color, all that. OpenGL, you got all the terminology that like I don't know, GL underscore vertice or vertex, whatever they call it. And if you want to make a cube, you need to like actually tell it where the points in space are. So this is way simpler if you're just wanting to get started. Okay, so we want to make our first, basically a callback sort of thing that we can use on our game engine. So we are going to create a public abstract void, and we're going to call this onLoad. This onLoad is going to be something we use to basically start or create new sprites, or the game objects themselves, tell the game where the sprites are, and all that fun stuff. That being said, I actually didn't prepare any sprites at all for this stream, so I might have to go download some. That's if we even get that far. I think we will, though. But yeah, now we have this abstract void, which basically is just sitting there. So before we run or start the actual window, we want to basically call onLoad. And then inside our demo game, we should now have an error saying that not all the interfaces are implemented, or abstract classes rather. So we can just implement that, and now we have onLoad in our game engine. And to make sure this works, we can say something like console.writeLine. Yay, onLoad works. So if we run this, our console, there it is. Our console now says, yay, onLoad works. So this one here will be used for loading our sprites, our game objects, our UI, anything that needs to be loaded into the game before the renderer starts. Now, what we want is an update function, right? We can't have a game without an update call. We need to get key input and all that, so we need an update call. This update call will also be used to render stuff to the window. And what we actually need to do is say window.paint, because that's what the rendering call is called for the Windows forms. By default, Windows calls this window paint, but I'm going to rename this to renderer. And basically inside of here we want graphics g equal to e.graphics, and now with that we can say something like g.fill rectangle, and we have all of these draw stuff that we can use. However, if we do that, this will run only when it needs to. So for example, if I play this, it has nothing there at the moment, but right now this window isn't actually redrawing itself. If I put it off screen and then bring it back, it actually forces itself to redraw. We have nothing there to test that. But what we want is a new thread that will basically tell Windows to force call this this every like millisecond or something. So we have our system.threading. Now we want another private, and we will call this thread a game loop. And to start off, we'll make it null. I will call it game loop thread actually. And then over here we will say void game loop. And then we will say before onLoad, or actually we'll do it after onLoad. And then we will say game loop thread is equal to new thread, and we want to pass in our void, which is game loop. And after that we will say game loop dot start. So this will now basically call this function as a different thread, and what we want to say is while true, then we do something. So this is now a game loop. We could say something like, I think we can say, well, game loop thread dot is alive. So basically, so long as this thread is running, it will continue to loop. So then anywhere in our code, maybe we have an onClose abstract. We could say something like game loop thread.abort, and then this will correctly stop our while loop. Otherwise, we will end up running into problems where the game will close, but then you still have this thread kind of running in the background, and then that will cause a kind of memory leak. And yeah, we don't want that. Nice coffee to drink while coding. Feels good. Oh yeah, I never ended up turning that music back on. Let me do that. Okay. Now we want to force our game loop to basically render. And it's basically we want to say window dot begin invoke, because we can't actually call any of these from another thread. We basically need to break windows and say, I don't care what thread it's in, you are going to call this function regardless of what you're doing. So we need a method invoker and a delegate. And then this delegate will be responsible for calling window dot refresh, I believe. And that should be it with that. So now we have successfully broken Windows, basically telling it to constantly refresh something that it doesn't want to refresh. And we also need to add a thread.sleep, and we'll add a delay of 1. Why we add this delay is because you do need to give Windows some kind of leeway when refreshing, because it does take time. So if we give it no delay and it constantly refreshes, it'll actually refresh on top of a refresh call, and then you will just get a frozen window. So you need to give a little bit of delay here. Now we can actually have a public abstract void on update. And you know what we can actually do now? Instead of onload being here, we can make onload before the game loop starts, which makes more sense because that basically means everything is 100% running before onload. And then we have update. And I believe we want to... Can't remember if we want to call update after or before drawing a frame. I think we do this. I think we say on update, and that's after the frame. But then we also want another public abstract void, and we say on draw. And then on draw is before the frame. So if we want to do anything to do with drawing into a game inside the update, we want to use on draw. If we want to do anything regarding movement or physics, we want to use on update. So now our demo game will have some errors because those aren't implemented. So we can say implement. And to test all of these out, we can basically just say console.writeLine. And we will just say, I will create an int, we'll call it frame equals 0. And we will say frame count, and then we will pass in our frame. So now our console should spam with how many, cannot be called on control until window handle has been created. Okay, so basically it's giving an error because our thread starts before our window even runs. So we should be good to, I mean, here's the cheat way of doing it, right? You just try catch everything. and that'll be fine because we can do something like this, try catch, and then we can say console.write line, and we can just say something like window is, or rather game is loading. And that's like a real like hacky way of catching that error. So if we start that now, our frames are not counting. Did I even make the frames count? I don't think I did. No, I did not. So we'll say frame plus plus. So now our frames should count. There we go. We are pumping out some frames. Hooray. So if I pause this now. Oh, wait. I stopped it, not paused it. If I pause this now and go to the console, you can see that before everything goes, it says game is loading, and that is primarily because it is waiting for our application to run using a try catch, and then it will run. Great. So now we have a renderer in our game that can render things. So the first thing we can actually try is g.clear, and this will be the color that is used to clear the screen every frame, every time it is refreshed. So technically this is your background color. This is your skybox in basic terms if you want to just use a solid color. So just to test it out, we can say clear and say color dot aqua. So if this works, our background should change. There it is. We now have a different colored background. And now we want this to be something we can actually set in our game engine. So we can just make a whole bunch of publics for anything we want to access in our game, and we'll just call this a public color. And we'll call it background color. And I think that let's just make it, we'll keep it background color. And then for clear, we'll just say background color. And we also do want to give this a default color, so equal color dot I don't know, beige. So if we don't set it, there we go, we've got a beige color. So now on our game, on load, this would be perfect to call the changing of our color. And maybe we want it, we also want to be using the system.drawing so that we can set colors. So now we want to be, we can change it to anything we want here basically. I don't know, let's change our background color to chocolate. Sorry, not on draw. We want to do that on load. We'll actually swap these two around. Makes more sense with on load being up here. So if we play that, we now have a that's actually disgusting, a chocolate color. The worst background I could have chosen. But to make other things easier to see for now, I think we're just going to set it to black. So setting the background color is now very easy. Fantastic. And now since I didn't get any sprites ready, we're gonna make sort of try to make anyway, sort of two renderers. The first one is just gonna be like a primitive shape sort of thing, sort of like what Unity does, and it'll allow us to draw just basic shapes to the engine. So I think we create a new class and we call this class shape2D, I think. Yeah. It will be a public class. We want a public I don't know what shapes Windows actually has by default, so we'll just default this to like a rectangle to start with, and then we'll be able to change its size and shape. So we want a public vector 2. This will be our position, and we will make this equal to null to start off with. We'll then want a public vector 2 for our scale, again equal to null. I believe that is it to start with. And then we say public shape 2D, and we want to pass in a vector 2 position and then a vector 2 scale. So then we can say this dot position is equal to position, and then this dot scale is equal to scale. Okay, so this is kind of the start of it. However, we want this shape 2D to kind of register itself with the game engine whenever we create a new shape like this. So inside the game engine, I believe what we want is... Okay, so I think it needs to be a public. So we'll put it up here. And we will say... what will we say? Actually, if we just say something like list shape 2D, we'll make it a static. And then we'll call it all shapes equal to new list shape 2D, and then we do express engine dot. Actually, wait, can we? Express engine dot, no. Because I don't really want this to be accessed by anything else, so we will make it a private static. However, we will make a function that can access this. So maybe above the game loop, we will say public static void register shape, and this will require a shape 2D. And what this is going to do basically is shape 2D shape. This is basically going to say all shapes dot add and shape. And now what we actually want, I forgot we actually want a name for this, or rather a tag, so public string tag, and this will be to identify this object if we ever want to. And so after all of this, we will say, string tag. Then we have this dot tag equal to tag, and after we do all of this, we want to call express engine dot register shape, and we want to pass in this. So whenever we create a new shape in our game engine, that shape will automatically register itself with the game engine. And this can be called from the demo game as well, so you could technically do this yourself. However, the shape does it for you. So what we want is, I guess, now a way to delete the shape. So we'll just say unregister shape, and then we want to say dot remove shape. And then we will have maybe on the shape we can just say public void, or it could be a static and we pass in whatever shape we want. Right, nah, we'll just do this. Public void destroy self. And then we will just say expressed engine.unregister this. So this will remove it from the list, which will stop the engine from drawing the shape. Great, so now we want to make the logic inside our render call that will use all this to draw a shape to our screen. Shouldn't be too hard, right? So, the background color, I believe, is always the first thing we want to draw. So this is going to be clear first, and then we want what do we want here? We want a for each shape 2D. We'll call it shape in all shapes. Then G dot fill rectangle, fills the interior of a rectangle. Yeah. And then we just say new brush, right? Or new solid brush. Color dot. Oh yeah, that's another thing. We didn't specify color, but for now we'll just make it red. And then we should be able to have like, yeah, just in the X, Y, and then height and width and whatnot. So now we should just say shape dot position dot X, shape dot position dot Y, shape dot scale dot X, shape dot scale dot Y. So that should be it, I believe. We should now be able to draw shapes or rectangles rather inside of our engine. So if we get to our demo game, and again we want this to be created on load, should be able to say shape 2D player, let's just call it, equals new shape 2D. And the first vector to which was the scale, no position, we'll just say 1010. Then the next, which is the scale, we'll say, we'll just say 1010 again, and then the tag, we will just say test. So on load, we should now have a shape that draws. There we go. We have a little red rectangle that draws. And to test out the movement, we can say, we'll say float x equals 0. And actually what we can do, we want to make this a variable we can actually use in the entire game object. So we'll move that up there, we'll say player equals on load. Stuff that you would usually do in Unity anyway. Then we should be able to say something like player dot position dot x plus equals x, I think. And then we can say something like 0.01. This is something that Unity doesn't allow. It doesn't allow you to specifically change a single point in the actual transform, but we can do it here. So that should move our rectangle. Yeah. Let's make it a bit faster. We'll maybe make it 3. But we have a rectangle that now moves. Let's make it a bit faster. Let's make it 0.1. There you go. We now got a speedy boy rectangle. Woo! Our game engine is looking like a game engine. And so we could do some funky stuff like say player dot scale dot x, and then we make that equal to x as well, so it'll move and scale along the x as well for that trippy loading bar effect. But yeah, you can see just with a simple drawing call we can start to do some pretty interesting stuff. So basically we can use the shape2D call to kind of debug our gameplay. Okay, so I think the next thing I kind of want to do before we go really heavily into this, I kind of want to create a logging system for the game. or for the engine rather, because console.writeLine is a little bit annoying sometimes. So we are going to create a new class, and I'm just going to call it log. Public log, and then we can say something like public static void log, I don't know, normal, I suppose. And then this will say console.writeLine, and then we'll just have message, and we also want to pass a string message, and then this will be our message. So we can also do some fancy stuff with the console. How can I forget this? Console dot forecolor. Yeah, that's the text, I believe. And for this one, we are just going to make the message console color dot white. And whenever we end this, we always want to turn it back to white anyway, because that's just the default console color. So now let's kind of set this up. So we'll go from normal to info, and then info will be dot cyan, and we'll make this say info, and then we'll go to warning, we'll make this say warn, we'll just say warning, and then this will be dot yellow, and then the last one would be our error. So we will say error, and this will be error, and our console color will be red. Okay, so in our engine, let's kind of start using that a little. So up here we can say log.info game is starting. And then over here we can say log.error window has not been found, waiting. I think that's all the logs we really need here. And then maybe in the shape, right, we want to say log.info, and then we will say something like I will say, can I do this? We'll say tag shape, I don't know, how should we format this? So shape 2D with this tag has been registered, and then we will just say above here has been destroyed. So now that we have that basic login system, if we start that, we should now unpause. At the start of our console, oh yeah, so it is working, but it is kind of all on the same line. So if we stop that, go to our log, we are currently doing write when we should be doing write line. And on top of that, let's remove that spammy frame counter, because that was just a test to see if the frames are actually working. There we go, so game is starting, and it has been registered. I don't know why this one's not working though. Kind of weird, but that should be good for those. So now to test the object being destroyed, let's, oops. Oh, there we go. I closed the window and now it's giving me this error because the window has been destroyed. So instead of it being waiting, we'll just say game has not been found. Okay, so let's kind of make a temporary timer. So that frame counter we had, let's just kind of just say time equals 0. We'll say something like if time is greater than, I don't know, 400, then we can say player dot destroy self, and this is, so then what we need to do as well is if player is not equal to null, because once it destroys itself, I believe, actually it kind of will still exist, right? Because all it's doing is it's not registering that shape in the engine. So we don't really need to do that, but we're gonna have to figure out a way to handle it correctly later on down the line. So if we start this, not working. Huh. Let's see. So we do destroy self. It unregisters the shape. The shape should be removed from the list. And since this is constantly updating, it should remove the shape. Oh, once again, I forgot to say time plus plus. So let's try that out. There it is. And has been destroyed. So at the moment, this isn't actually removing the instance of the shape. It is simply unregistering it with the game engine. So eventually we're going to need to figure out how we can destroy the shape itself and not just unregister it. Can we do something like this equals null? Does that work? No. What do we have? Yeah. Eventually we'll need to figure that out. I mean, for now it's kind of enough to just destroy it from the game engine. That'll be fine. I mean, it's still gonna save like processing power because it's not actually using this on a shape, but it is technically, the shape is technically still in memory. The easiest thing to do, right, when we destroy the shape would be to also set the shape to null, and then we can say if player is not equal to null. So that would be the simplest way to correctly destroy that shape and remove it. So you can see now it's basically registered and only been destroyed once instead of spamming that destroy call. So basically that's it. So if we want to correctly destroy it, we just need, well, basically this entire if for an object. But yeah, just testing that to see if it actually destroys it. Okay, so what I might do is go to itch and get some assets. But how do I open file in Explorer? Okay, so I am going to create. So inside, so I've got basically the debug here where the game project is compiled. I'm going to create a new folder called assets, and inside that assets folder we will create sprites. So let me just see. I think I have a whole bunch of like the Kenny assets. Oops. Just give me a quick second while I log into this. If I can even remember what my login is. Okay. So how the heck do I view my downloads? Okay, there it is. Okay, so while that's downloading, hopefully it doesn't affect the stream too much, we should now just kind of check it out. So we should be able to say something like draw image, I think. Yeah, and this requires an image and a position. Oh, I can't remember how to use it though. Bitmap. Yeah, I think this is how we want to do it. And we should be able to say from file. Yeah, bitmap from file. Okay. Okay, I think it's coming back to me. I think I remember how to do this. So, let's create a new class. Add class, and we will call this one Sprite 2D. And say public class Sprite 2D. Basically, we need the same stuff as the shapes, so I'm going to copy and paste this, except this will be Sprite 2D. And so we have position, scale, tag, and now inside our engine, we also want a private static list of our Sprite 2D, and we'll call it all sprites, equal to new list. Okay, and at first, let's register the sprite. We'll say sprite and sprite. Then we will say all sprites dot add sprite. So this will be Sprite 2D. Okay, and basically the same thing as we did before. Unregister sprite. All sprites dot remove. So inside here we want to say register sprite, and then next we'll just say public void destroy self, and then we'll say express engine and register sprite and this. Okay, so at this tag we want to change to a directory. directory, and then we'll also say public string tag. The directory is going to be used for the actual location of the sprite. Oops. So now we can say this.tag equals tag. Okay, still downloading those assets, but we should also now be able to say, let me quickly see. So we have g.drawImage. What does this want? It wants an image, so we should be able to just store an image inside of our sprite. So public image. Ooh. I think we need to be using system.drawing. So public image, and we are just going to call this sprite and make it equal to null. So before we register the sprite, we want to say something like sprite equals image.fromImage, I believe. Yeah. Okay, so those assets are done. So this Kenny asset pack kind of has a few things here. I really want to be in the 2D and maybe the abstract platformer. What's the preview? Yeah, we got some players, we got some platforms. I think this will be a good pack to just start. So we should have some PNGs here. Yeah, also some backgrounds. Okay, that's nice. Okay, so basically inside our assets sprites, I'm going to drag all these folders in there. Okay. So we have, I should drag it back. So we have some enemies, that's cool. Main thing we want right now is players and tiles. So, green tiles. Okay. So it's not exactly, I mean, it's alright, it'll do, I guess. Kind of thinking about how we can make like sort of a tile map system. But we'll get to that after we figure out how to cute sprites. Yeah, Kenny has some great stuff. Okay. So we should be able to say image.from. Actually, how can I do this? I think bitmap, right? Equals locate sprite. I'll say equals new, or rather image.from file. Then we want to say I want to say sprites. No, our first assets. Is that what we call it? Yeah, assets / sprites / and we will do this to make our life easier. And then we want to pass in directory. Does this not allow? Wait, what? Can I implicitly convert system.drawing.image to system.drawing.bitmap? As bitmap? Okay, that works. So basically we are only going to pass in the directory, and for now to make our life easier, the only thing our game is going to accept are .png files. So we should be able to have inside Sprite, yeah, width, height. Okay. So what is the height referencing? Get the height in pixel. Oh, it's only getting it. So can we set it? See, well, I think this will work. This will make it the exact size of the sprite, which is kind of not what we want. What happens if I do dot image? What do we have here? Okay, so I think what we might need to do is this, right? If we want to have a image, we'll call it temp equal to image.from file. And instead of sprite being an image, we want sprite to be a bitmap. And then we should be able to say equals new bitmap, and we can actually pass in, should be able to pass in a size. Yeah. So we actually want to just use the scale. Oops. And again, this needs to be this. So this and this, and I believe this needs to be an int. Right. Wait for it to string. What? Yeah, int. Okay. And then there's some other stuff we can do. Let me see. So like pixel format, what does that give us? Okay. And let's pass in alpha, I suppose. Okay, so now we want to somehow set that sprite. Do this. I completely forgot how to do this. Is there a set pixels? Set. I've set pixel, but not set pixels. Is there an image? No. We have lock bits, we have get bounds, get pixel, get type, make transparent. Let's not get thumbnail image, is it? No. Alright, I'm gonna just look up real quick how to use bitmap again, because I've completely forgotten this. Can we change the size of the image? Hold on. Is it only getting or... Actually, what about here? Can we pass in something else? No. Maybe there's something in the bitmap. Has to be some. Oh, hold on, image. Okay, so can we pass in image and a size? Image and width and height. Okay, so we want to pass in temp, and then this dot scale dot x, and then this dot scale dot y. Okay, okay. So, and then these need to be int, of course. Why? Oh, okay. I think that might work for us, I think. Yeah. I think that's... So this is a temporary image. We then store that inside our bitmap, which is a sprite. I think that is good to go. So let's try adding that to our engine now. So for each sprite 2D, sprite in all sprites. We now want to say g.drawImage, and then we want sprite.sprite. Yes, yes. And we should be able to say, should be able to just give it, yeah, here it is. So sprite.position.x, sprite.position.y, sprite. I mean, I don't think we even need the width, right? Anyway, sprite.scale.x, sprite.scale, oops, sprite.scale.y. Okay, that might be it. We might now be able to start drawing sprites into our game. So let's give it a shot. So now in our game, let's just disable this whole player thing and make player a sprite 2D. Then player equals new sprite 2D, and then we want a new vector 2 for our position. We'll do the same, 10, 10. And then a new vector to scale. Maybe we'll make it 2020 this time. And directory. So the directory should already be, so we have assets and sprites, so it's whatever is in here. So we have players. So players slash we'll use the green ones. So oh, that's grey. Alright, whatever. I can't read. And then maybe this little dude. And we don't want the PNG because that's already added for us. So that should be it. And we want to tag, and we'll just call that player. So with any luck, we should now be able to draw that little guy. Damn, close. The image cannot be null. It's not though. Oh, yes it is. So at the end of all this, we want sprite to equal sprite. There we go. So now that should correctly set it. There it is. We got a little dude. Okay, so since it's scaling for us, can I just remove the scaling from this? I can. So in our game engine then, what's the actual size of this sprite to test it out? 36 by 45. 36 by 45. There it is. We got our little dude. Our first non-cube in our game engine. Woo! And now we should just be able to do the same thing technically for that guy. So we can say something like, oops, float x equals, I don't know, 0.1. Then player.position.x plus equals x. So now our little dude should zoom across the screen. There he is. He's a speedy boy. Woo! And the scale, just to test it, should be the same. So scale.x, and then if we do the same thing, he should now move and stretch. Yep, he does. That looks horrible, but he does. That's great. Okay, so we now have technically something to work with to start building a level. I know, it's a big step up, but I think we can do it. So, what we want is kind of a multi-dimensional array that'll act as our sort of points in the world, I guess. So I believe what we want to do, is say something like string. It's gonna be a multi-dimensional array. Let's call this, I don't know, map, or rather room 1. No, we'll call it map for now. And we'll just do this. So we should be able to just...
It's not exactly clear whether they even truly exist or could be shown to
Right?
in
So this is how we make our map. So let's copy and paste this a few times. Maybe like that. And maybe we will make the letter G our ground tile. And you know what we can do? We will default the period as just an air. Just like a gap in space. So let's do this, and this is just so we can actually format it and kind of see what's going on. Okay, so now let's just do this. Okay, so we'll have like a full bottom ground sort of deal here. Maybe we have some blocks up here, kind of forming into like a pyramid shape. And then you get like a little Mario jump at the end. So, how can we use this multi-dimensional array? We should be able to say for int I equals 0. I is less than map.get length 0, so this is our first length, I++. And then for the next one, let's call it j, and we want to get length of the other array inside that. So since our game engine doesn't require us to like constantly hold a reference in the game to a sprite, we could technically just do this, new sprite, but then we lose track of everything, right? So we can say something like new sprite position, new vector 2, and then we can say I and j just to start off with, and then new vector 2. Wait, why is it I and y? We want I and j, and maybe we'll make the scale 20 by 20 just for now. And then we want to actually get the ground tiles. So it's sprite slash tiles, sprites slash tiles. We've got blue tiles, so we'll use those. Slash blue tiles slash, and then we kind of want something, yeah, I think this is a nice one. And we don't want the PNG, so that should be good. And a tag, we will call it ground. Okay, so if we leave it like this, this will fill our entire array with that block, which we don't want. So we kind of want to say if map I and j is equal to the letter G, then, only then, do we want to actually create our sprite. So right now, you need to understand this isn't part of the game engine, this is part of our game. So if we start this, it's not found. Okay, I've done something wrong. So back to our demo game. Oh, we don't need to add sprites. It's just tiles, something like that. So if we run that, we should now index what's outside of the bounds of the array. What? Really? What am I doing wrong? J. Oh, we want to make sure we actually increment J as well. So that should now work. Yeah, there we go. So it's kind of all clustered in this one area, right? Because we are only moving it by 1 pixel. So I think how we can fix this, we get the width and height of the actual tile here. So it's 64 by 50, so I think if we just times it. No, I think timesing is the wrong way here. That's gonna make it kind of go crazy, I think. Yeah. Plus maybe? No, that's just offsetting it. Okay, I think times is the way to go, but it's not how I'm thinking it's going to work. Let's just do 5 by 5. Almost there. 15 by 15. Almost there. Oh, right. Actually, I'm just stupid. Because the size is 20, and so we obviously want to offset the position by the same size we're actually using. Yeah, there we go. So that makes a little more sense now. So 2, 3, 4, 5, 6, 7. Hold on, what's going on here? Oh, it's flipped, I see. This is interesting. So it does draw correctly, but it's flipped. So instead of this being our ground, it is going like this. So going from top to bottom, that's our ground. I can't remember how to flip arrays though. We might also actually just make the tiles themselves kind of bigger. Wait, what? Oh. Okay, so I don't think it would matter if we flip this around. If we do 1 and then 0. I think it'll just, I don't know, let's see. Yeah. Actually, I think we need to do J and then I now, right? Oh. Wait, that worked. That was just a hunch. Okay. But that's awesome. Now we have a way to actually make levels. So I could edit this. I could fill these up. And maybe I'd only want 2 little spots there for our ground. There we go. So that's awesome. We now have some way to draw a ground inside the game. And now I'm just trying to think here, what can we do next? I think the most obvious one to do would maybe be a camera, so we can position the camera, which I can't remember how to do. I think it's transform. Translate transform. Yeah. So, I mean, this is easy enough. We can basically just create a public vector2, call it camera position equals vector3 0 0. Oh, actually, we made this vector2.0, but we never ended up using it, so we can just do that. So now we should be able to just say g dot translate transform to camera position dot x and camera position dot y. So I think that should just, yeah, so that's by default. So maybe we try to center it a little bit. So on load, let's say camera position dot x, maybe I don't know, take what equals 100. Actually, now that I think about it, I don't think that's working because we're translating after we position all the objects when we need to translate before that, I believe. Yes, there we go. So we now have a camera that can move our scene. So again, we could do the good old add test by on update. Maybe we just say plus plus instead of doing what we've been doing. And there we go. We now have a camera. And we could say plus equals 0.1. There we go. A working camera. Very basic and very easy to implement with the Windows Forms, and probably not performant whatsoever, but we have a camera. We can position it. And let's see, can we now rotate? So g dot rotate transform, and that wants an angle. Okay, so we will create a public float and call this camera angle. And we'll just start it off as 0f. Okay, so now let's just say camera angle plus equals 0.1f. So now we should move and rotate. Yep, that's some funky stuff. Let's make it a bit faster. Get that real camera shake going. There it is. That's the camera shake we all know and love. But yeah, I'm happy with that. Awesome. You can see it's kind of offset to the corner of the screen. There's not really much we can do about that, but I mean, we have it, just for a bit of camera shake if we ever want some camera shake. Alright, so we've done all this stuff. Now, the most obvious thing to do, which the game still can't handle, is some user input stuff. So I think the most obvious way to do this with Windows is to get the key up and key down and then handle how long it's been held within the game itself. So underneath Windows.paint, we'll say Windows.key, I believe. Because when a key is being pressed, while the controller is focused. Yeah, so key down. Oops. And then we want to key up. So window.key up. Okay. So I think we can say something like if e dot key code is equal to keys dot, yeah, and then this has a lot of keys. And that should work. Yeah, so very similar to how Unity does it with Windows Forms. But we want to send all that information off to our game. So let's say public abstract void get key down. And what event is it that we want? Where is it? We want the key event arguments. So get key down, E, and then get key up. So now we can say get key up and pass through our E, and then we can say get key down and pass through E. Now in our demo game, it wants us to implement those. There they are. And we should have keys implemented, yes. So now in here, let's create some booleans. So let's just say bool left, bool right, bool up, and bool down. And now on key down, we can say if e.keycode is equal to keys dot I don't know, w. We can say up equals true. And let's make this a little bit easier to read since it's not actually that big. So we'll do it like this. Copy and paste it 4 times. So W, then we want S, A, and D. So this will then be down, A will be left, D will be right. And now for key up, we basically do the same thing, but set everything to false. So, false. Let's do this actually. Oh, it won't let us do this. Okay, whatever. False, false, and false. And then on update, we can say if up. Why is it always doing this weird offset? Hello. Okay, so copy and paste this. So if up, if down, left, and right. And now let's get our player sprite back. And after we draw the map is when we want to set the player. So player equals new sprite 2D. We will say new vector 2. Maybe make it positioned by 30 by 30. New vector 2 for the scale, so 50 by 50. And now we want players slash, let's actually get that green player now. Slash player green. And get like that kind of walking animated one. And then a tag of player. Okay, so now we can say player.position.y. I think up is tag equals, so we'll say point. We'll just say 1. Let's just set it to 1. Down plus then position for x, and then position for x plus. So now we should have some user input. We have a very stretched out player, but there we are. We have a fun game, AAA. Let's get it. You can get it now for $9.99. So let's I believe the player needs to be stretched out a little to make him look more like the reference. I think we're overstretching him though. So we'll do 40, and actually his main scale was like 36 or something, so we'll just say 30 and 40. And there we go. We now have a player. I honestly thought this was going to take us longer to actually get something to the screen, but an hour and a half for this, that's pretty good. Now, another thing to note is the way Windows rendering draws is whatever draws first will be behind whatever is drawn next, right? So the player can go over all those objects because we draw him last, but if we draw him first, you'll see that we are behind all these tiles now. So depending on if you want the player to be behind certain things or in front, you kind of need to think where you want to put this line of code here. For now, I'm happy with him being in front of the tiles because we can actually see his cuteness. Okay, so I think the next step, right? So let's not add any physics for now. Let's just make a game that doesn't require any physics. So this tile set, players, no, Sprite, tiles, we went for the blue tile. It has this that we can use for a wall. So let's kind of do that. And then kind of make a little level for us, like a kind of top-down sort of dealio thing. And so we kind of want this to be around the entire map. And then maybe we have a like a room the player starts in. I think it's small enough for us to just do this. And then maybe it goes like this, and like this, and then maybe like that. So now we have a bit of an interesting sort of map here. Top-down map. Player will eventually be able to move around. So what can we do? I think now we just want some basic AA BB collision. Now this is something that I don't remember how to do for the life of me. So Google is your friend, And I'm literally going to just type in math for AABB collision. And there should be some algorithm here somewhere that will let us do this. Okay, this is not exactly... Okay, no. Simple AABB collision. Okay. Do this so you guys can see actually. So I kind of remember this stuff, yeah, but you have min max. That's so I'm assuming one is position, and then the next is scale. However, or is it referring to the next? So 0 is the other object, I think. Okay, let's try it out. So let's do it on Sprite, and we'll say something like public void is colliding, and we want Sprite 2D A and Sprite 2D B. Oops. So we should be able to say, oh, and actually let's make this a boolean, not a void. And for now, let's just return false, because if it doesn't do any of this, it will be false anyway. So we should say if a dot hold on, min and max, is min the position and max the scale? I think it is. So min will be position. Oops, so a dot position dot x is less than or equal to b dot position dot x, and then a dot scale dot x is greater than b dot scale dot x, and a dot position dot y with b dot position dot y, and then a dot scale dot y with b dot scale dot y. And so if it does all that, then we return true. So if all of those, yep, okay. So let's see if that works. I'm just thinking though, because this was object to object collision. Okay, for now, let's do that. And so demo game. Let's just say something like player 2 and copy and paste the player here as player 2 and x something like 100. And then let's just say player dot is colliding with player and player 2. And this is actually something that should be done inside the update. So we'll say if they are in fact colliding, then we want to say log dot info colliding. So let's try that out. So So this does work. Oh, okay, it's just already colliding. Uh, ba -ba 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 -ba. I'm not sure if it's position at once first or scale. That's the problem. Let's try scale. Right. Scale, position. Scale. Position. Alright, let's try that. Okay. Wait, what? How's it modified? Literally doing nothing. Okay, yeah. Oh. Hold on. Okay, so it's registered and... Okay, so as soon as you touch it, it's kind of working. So if I like, as soon as I get on the other side of it, it'll work. Or is it scale, scale, position, position? No, that wouldn't. No, that wouldn't. Okay, let me look at another example that's a little more clear. Okay, let's try this one. So, if a dot position dot x is less than b dot position dot x plus b dot scale dot x and a dot position dot x plus a dot scale dot x is greater than b dot position dot x and a dot position dot y is less than b dot position dot y plus b dot scale dot y and a dot position dot y plus a dot position dot a dot scale dot y greater than b dot position dot y. And that we want to return true. So let's see this method. Oof. Okay. Hey, there we go. Okay, this method worked. Let's what can we do? Let's go to the demo game. Let's just say int times equals 0, and every time it collides we'll say times plus plus, and then we will just put times inside of here so that we know it is not looping or repeating. Wow, it takes a while to initialize the window. And there we go. So there you go. Yeah, we're now correctly colliding. And hopefully if we, for example, make one of the players larger, we should still get an accurate collision. Oof. What happened? Position scale, why did it not like that? Okay. Sometimes it just doesn't like it. So try and just touch, there we go. Yep. Seems like we're still getting accurate collision even though we have scaled up the object. Awesome. Oops. Fantastic. Now, don't know if I'll have enough time to do this. I have like 5 minutes left before I have to head off, guys. Okay, I think we will need to make these lists public for what I have planned at the moment. And we will make another is colliding, however this one will be with a string. And then we want how can we do this? You basically want to get all the... No. We just want to get... Because we're going to be using our own object as reference, but we want to get every other object with this tag. So we're just going to call this tag. So I believe we can say something like for each sprite 2D B in express engine dot all sprites. Then we can say if b dot tag is equal to tag, and then we can do this. And instead of it being A, we now just reference our own object's position. So this should now allow us to actually detect collision with entire tags for a single object. Instead of saying is colliding with player, let's just say is colliding with the player tag, or player 2 tag, and then give this guy the player 2 tag. So we shouldn't see a change. Collection was modified. Why does it keep doing that? I don't think it actually closes the application correctly. We might have a memory leak somewhere. There we go. So shouldn't be a difference. There we go. So we're now colliding with tags rather than the single objects. So this now means we should be able to say colliding with ground. So we want, and we no longer want this second player either. So now that we have the collision, yeah, we've got some sort of memory leak that stops it from opening every second time. So yeah, now you can see it. We're not colliding, but we are colliding with all of these objects now. And you know, there's no proper physics or anything like that right now, but the fact that we're now able to collide with anything with a given tag is great for us. So we could kind of make a hacky collision sort of thing, I believe, by saying something like, so we can do this. So if we aren't colliding, we actually want to create a temporary vec2 player position, or we'll call it last pose, and say equal to vector2.0, and then if we're not colliding, we want to say last pose equals player.position. However, if we are colliding, we want to say player.position is equal to the last position. This should stop us from moving. Actually, we're going to be stuck, and we are going to not be able to move. Yeah. Oh. Okay, never mind that. Let's see. So if we're colliding, last position. Let's make the position 100, and we kind of just want to start the player off in an open area where there's no collision, just to make... Oh wait, that's a scale, my bad. So 100 by 100, where does that put us? What? Oh. I was confused there, why was he... Oh, come on. Okay, this memory leak is annoying me now. Okay, so we're not making any collision at all here. Let's continue logging to make sure we are still colliding though. Wait, are we not even... There we are. We are colliding. Okay, so I think... I don't know, let's try this. Let's move everything before we move positions. No. Can't remember how I did this. It's like a really hacky way to stop the player from moving. So, it's colliding. We want to set apply position to the last position. I think the problem might be because we're not really giving it space to think. So... Let's add like a... So this time value. Let's make this time value just continuously increment, and then we will say something like if times is greater than 10, then we want to do this. Oh my goodness, what? And we want to do that, and we want to set times back to 0. I just want to see if we get any kind of jumping at all. Okay, what's... Oh. This damn memory leak. Just let me play. Okay, so... we should be able to move... Okay, we're getting no jumping at all. I'm wondering, let me see if this is even setting a position correctly. Let's see if we are colliding. Let's go back to vector 2.0. Does that actually set our vector 2 correct? Oh, god damn this thing. Stop it. Stop it. Let me play. Oh, collection of the modified. Okay, something is... Question is modified and may not be executed. Is it this vector? Is it this? It's a vector 2. Alright, let's just do this. What? Let's do this. Not do any of this at the moment. Okay. That's so weird. Okay, so I think... Let's see. If I do debug... not debug, sorry. I'm thinking Unity here. If I do log.info and then pass in lastpose.x plus lastpose.y, is that actually setting the x and y from the player? It is. Huh. Then we shouldn't have a problem with it setting it back. Just in case, let's do this. A new vector 2. Actually, I think I might know why this breaks. It doesn't want us to set the vector. So we need to actually set the position like this, I think. So we should be able to just say last position.x and player.position.y equals last position.y. Yeah, we'll see if that works. Okay. Oh, we didn't. Oh yeah, wait, we did. Okay, let's do it that way for this as well. So .x and .x. Okay. That's so weird. Just trying to think why it would be breaking. I don't see how any of this should be breaking it right now. It's just really odd. Yeah, it does it sometimes and not others. It's weird. Ah, there we go. We have collision. Woo! It's very basic, but it's there. Now we can start kind of seeing how a game can kind of play out here. So we could now place some sort of coins inside of this map. It's kind of really snappy. The only downside to the Windows stuff that we're doing here, right, is everything is set to the current scale of the window. So if I start to scale this, let's not scale it. Let's not. Crap. I broke it. Windows didn't like that. Oh shit! It's actually locked up my computer. All I wanted to do was demonstrate something. Alright. Task manager, help me. Okay. Never scale the window while it's running. Lesson learned. So, with that being said, let's say Windows. Oops. Window dot type, no, border mode, I believe, equals, and let's make it a fixed tool window because I never want it to do that again. Oh come on, you and your memory leak, just do something. You know what it might be actually? Let's do window dot close, form closed dot quit, exit. No, maybe it is just form closed, form closing. Yeah, let's do that. Because we said this before, but we never actually implemented it. But the game loop thread could still be running because we never actually abort it. So let's abort the thread when we close. Okay, so if we so if we close this, okay, stop. Okay, there we go. I think that was a problem. We never actually stopped that thread from running, so there actually was a memory leak. Cool. So we have the basics of a game. Now we want to get some kind of collectible. So let's see what collectibles we have. Items. Maybe these stars. Yellow crystal. So let's go ahead and get some sort of, I don't know, maybe we will put C for collectible. So let's have maybe 3 there and 2 there. And then down here we'll say if if C, and then we want items slash, and I think that's it. And then we just want this. And I'm just going to give it the tag of coin. And you know what we could actually do in the Sprite 2D here? Because we only return a bool, right? But we could actually return an object, kind of like how Unity does. So let's return a Sprite 2D. And if we don't get a collision, we return null. If we do, we return B. So in the demo game now, instead of we say if is colliding with the ground, it's gonna pass an actual object. So if it's not equal to null now, and this should work still, and then this coin, we can say the same thing now. So if coin is not equal to null, then now that we actually and for this particular one, we will actually need to say Sprite 2D coin equals, and then this. Then in here we will need to say coin. And so if we are actually colliding it with it, we want to say coin dot destroy self. Ah, damn it. Okay, we still got that problem. Okay. Oh, those are actually really big coins. Where is? Okay, so we want to make the coins 10 by 10. Wait, that's the player. Wrong one. Coins. Maybe 15 by 15 with the offset of 15 by 15. Oh, this damn memory leak, just go away. Oh. That won't work because and they're going to be different offset from here. So I believe we can still scale it the same, but this map offset needs to be exactly the same. Oh, buzz off. Just let me run the game. Okay, there we go. So now we got coins around, and if we collide with them, they disappear. Woo! Gameplay. Epic moments. Okay. So, let's scale them a little tiny bit more. We'll get 25 by 25. And I think if we actually add on 25, that will center them, maybe? Oh, okay. I'm getting annoyed now. No, okay. 15 by 15. Half of 25. And there we go. They're pretty much centered on the tile now. But now we got this little dude that has a very basic collision. Basically, as long as it's not colliding, it's getting to the last position. If we collide on something, it sets it back to the last position. So there's basically no way we can break out of this area. If we spawn inside a wall, we will be stuck permanently. So we can collect these coins. We are happy. We can fill the entire map with coins. We now have... Oh, this memory leak. Please help me. Actually, let's try something here. Let's try this. So this, the renderer. Let's get... I'm mad at it. I'm furious at it. So I'm gonna try catch the entire thing. How do you like that? You can't crash my game now. So let's... Okay. So... Okay, maybe it can crash the game. Oh, hey, it loaded. Okay, it's just got some loading time. I don't know what it's doing. You know what it? Actually, I think I know what it's doing. All those images that it is reading, it's reading it over and over again. I think that's why it's taking so long. So instead, what we should be doing is if we're using the same image, we should basically hold it in like a public thing that we can reuse. So right now, all these stars and walls and all that is basically it's loading in all those images separately. And once it's loaded, it's fine, right? But I think that's why we kept getting that issue, because it kept trying to render images faster than they were loading into the application. But now we can collect our coins. Woo, we're a happy little green player, dude. Woo, there we go. Woo. Fun games, ready for Steam. $1 release. Yeah, you can kind of see, because this window is semi-laggy when you pick it up. And that is, I believe, because of the images. I don't think they're always being loaded. It's just... let's see. Can we optimize it just a little? I don't know. Let's try with this. Let's just say Sprite ground, and we want ground to equal this, and default will just say 0, 0. But then let's just say I think that'll work. No, I don't think that'll work. Yeah, I need to kind of... I should have planned it out better. I don't know. How can we make this work? I think how we make it work is... Instead of being forced to call this, we require a bitmap, and it just reuses that bitmap. That's an idea. That might save us some space. So we start off with one sprite. And we have position, scale, and tag, but instead of the directory, we require a bitmap, and we will call it reference. And we will remove everything here. And sprite will be equal to reference. Okay. So now what we should be able to do is let's create a wall or ground. So sprite 2D ground ref is equal to all of this stuff, and let's just position it out of the window so we don't see it. Just testing for now. And then we can say new sprite 2D, all this stuff, but instead of a string, we can pass in ground reference dot. Actually, we can just do this to make it easier. We can just, instead of passing in a bitmap, let's just pass in the actual sprite 2D. And then reference will be reference.sprite. There we go. So now we should stop a lot of that lag, because it's only using one image, I believe. So let's see. Okay. Still got a bit of that lag. But this is technically not using the bitmap over and over again. So let's do that same for the coin. So we'll say coin ref. Do the same thing, except give it a coin tag. And that's what we want here. And then we want to pass in the coin reference. Okay. So let's see what happens. That's not the right one. Okay, and now we pass in the main reference. Okay. Another thing we might try is the game loop. Let's slow it down by another millisecond. So instead of 1, we'll do 2. Not found. Have items slash like that. Alright. There we go. The window loads pretty much instantly now. Hooray. You can see the game is much slower now. But I think we kind of needed that. We kind of needed to give the Windows form a bit of a break. So yeah, our window doesn't lag when we drag it around. There is a bit of load time still, because it's still loading in those images initially. But instead of every one of these tiles loading into memory a new image, it is now only loading in those images once, and then we are simply referencing that bitmap over and over again. So ideally, we don't really care about these positions and whatnot. So what we can do is, let's say something like, so let's create a public bool is reference, and we'll make it equal to false. But the this one here, I believe. So let's make another one. We'll say, instead of wanting a position and scale, we will just say bool is reference. Let's also remove the tag. We don't care about the tag for this either. So we can just say is reference, or sorry, this dot is reference equal to is reference. So instead of having all this kind of bloat that we don't need, we can remove it and just say true, because this is a reference. We don't actually want this to do anything else. Hold on, let me see here. Oh, on the tag, I think we removed the tag, right? Yeah. So that's all we need for the reference. We make sure, and actually we don't even need the bool. We can simplify it further, because if we're just using this, it's already a reference. Okay, so we'd basically just set the reference to true. If we only set a directory, it is only a reference. That is how it is going to work. So back in our engine, right, we now just want to check if sprite dot is basically, if it's not a reference, then we draw it. If it is a reference, we ignore it, because it's being used to draw other sprites. So that is a pretty nice way to optimize it, to be honest. We kind of create a sprite as a reference. We then make a new sprite using that image as a reference, as it's just loading in over here. It's loading in the image we want it into memory. Then here it's simply reusing that image over and over again, and then we can use our position, our scale, our tag, all the good stuff. So this, yeah, look at that, snappy. That is really nice. Okay. You'll find because of the method of movement we're using for colliding, we're not actually using a genuine physics engine. If we actually like hold up against a wall and then press W to go up, we won't. So you need to make sure that you know we can go up against a wall, but when we let go, we don't continue holding W or any of that. So, I mean that's pretty much a basic game engine right there. You could technically bring this into a game jam and make something with it. We have, if we go back to our engine, we have form closing. We should actually make this our abstract void that we can use in our game. We'll do that later. But we have key up and down input. We register our shapes and sprites. We have our game loop. We have our renderer. We then have our on load and on update, as well as on draw, and then all our get keys. So that stuff can be used in our game. And the cool thing about kind of having so this eventually what I'd want to do is not have this kind of map system in the game. I would move this sort of tile system over to the engine itself, and I would make I'd kind of try and make like a room system. So this would be a multi-dimensional array within a list, and then you could kind of do like if index 0, then that would be level 1. If it's 2, then level 2, and you know, you kind of get the idea. But anyway, I think that's all I can do for now, because I have a few things to do. One last play, or rather, let's make a new level. Let's do this. Let's just make the level really big. I think that's big enough. And then we'll also do this. Okay. And let's do this. Whoa. Why is it doing that? That's weird. I don't know what's doing that. So let's just do this. So this is kind of like the ultimate test for it as well, to see how fast it handles doing all of this. So then we will, like always, do the outside edge of the map. And you know what we could do actually? I'll do it in a sec. We could actually make a point called P, and that's where it spawns a player. So that we don't actually need to mess with like the positions and stuff. It kind of just puts it where we want it. I'm just gonna do this. So let's see how well it handles that. Okay, it's very big. Let me do something real quick, because we had the camera, we've done the transform and the rotation, but we didn't do the scale. So we can actually, what is this one? Yeah. So let's do the scale so that we can zoom out. So camera, zoom. And so we will say camera zoom the X and camera zoom the Y. So if we play that, nothing should be different really. Parameter is not valid. What? Oh, maybe it actually wants the zoom factor, and 0 isn't 1, so do vector 2 1 by 1. That should be like a normal level of zoom. What do you mean? What the hell is that? Oh. Okay. Yeah, there we go. So that's yeah, that's a normal zoom factor. So in our game now, we can say on load, we can say camera zoom equals new vector 2, and I believe the smaller the number, the more it zooms out. So let's see. Yeah, okay, so we can see the entire map, it's just super small. So let's do like a 0.5. Yeah. Zoom in just a bit, maybe 0.7. Okay, I mean, 0.8. I want to try and see if it can fit to the screen as best as it can. Oh, that's perfect. So our collision should still work. We have all these objects. Our collision is fine. Okay. So let's kind of make a place where the player spawns. So this maybe will be the room the player is in. Like that. And in fact what we want to try and do now, right? So we'll put a P there, and then we can do if the map P, and then we want to spawn in the player at those coordinates. So this here. So 15, I don't know, by 20. Let's see where the player is positioned. Wait, what? P, that's P there. Let's do something like if player is equal to null. If it's equal to null, let's just return out of the update, just to make sure the position doesn't try and edit. Okay, so that's not the end. So player equals new sprite. We have the position. So let's just remove this stuff. See where it puts us. It's not really moving us. I don't think I'm setting a position anywhere else. We have position, we have scale. let's just, if we remove this, what happens? Okay, so it is moving us. Just not really how we want. So let's try this. Hey, there we go. So am I in the wall? No, I'm not. Okay. So we can now position our player wherever we want. And cause like we can try something here. Let's maybe have 2 player positions. Maybe put one there and there. I don't think it will spawn. Okay, it does spawn 2 players, but only the last one will be able to move. But yeah, now instead of just adding a position, we can now put P anywhere on the map, and that'll be our player spawn. So we could maybe make a corridor that we need to go up over here. Maybe it enters a big room. Into another large chamber. We'll have a divider here. A divider up here. Another divider here. So now we can basically just add our coins throughout the map. So maybe we'll have 3 coins here, have a coin in this lower area, 2 coins here, maybe fill up this entire chamber over here with coins. Down here, let's put some coins, maybe 1 coin up here, and then for the very end we'll also have a coin. So playing this, we should now have a map, and we do. That is fantastic. So we can move around, we have collision, we can collect our 3 coins, collect 2 coins, we got 6 coins in here we can collect, some coins here, woo! There we go. For 2 hours and 42 minutes, I am quite happy with the progress. I think this will be it for today. It was kind of fun doing, to be honest. I thought I was going to have more trouble than I did, but I guess I retained more than I thought in my absence of coding. But I think the next steps would be, if I did stream the development of this again, the next steps would be to add some sounds, and then maybe implement some sort of physics engine like Box 2D. Which is super simple to implement with something like this, and then we can actually have physics, we can have some, projectiles or something like that. But for now, pretty happy with this. Yeah, it's a game. It's not a very good game, but it's a game. But yeah, thank you guys so much for sticking around and watching this. I believe I've set it so that the channel should save the stream again, so if any of you ever want to go back or just see what the end result was of today's stream, you should be able to. I really appreciate all of you coming by, saying hi and whatnot. I will need to figure out when I'm able to stream again. I don't know. It depends on what you guys want, really. If you guys want me to kind of continue a stream where we work on like this game, not this game, but rather the engine itself. But yeah, I need to head off now. I've got a few things to do. Thank you all so much for watching the stream and being here, and I'll see you guys later on.